The arsenal of democracy, forged here at the mighty River Rouge. Day and night, the tools of victory are produced by the hands of dedicated workers.
How soon until the next shipment is ready for inspection?
We'll have 50 by nightfall, Colonel. The welding team is moving fast.
We need to ensure the armor plating meets specifications here.
I've noted the tolerance levels, Major. They look good.
We need these moved out by Thursday if we're going to meet the quota for the Pacific Theater.
January 1940. Detroit, Michigan. The River Rouge plant stretches like a steel leviathan under the gray winter sky. Smoke coils from towering chimneys, mingling with the bitter cold that bites at the workers' cheeks. Inside, the rhythmic clatter of stamping presses and the hiss of welding torches echo through cavernous halls. Rows of car chassis, once destined for the open road, now sit empty, waiting for transformation into instruments of war. Engineers lean over blueprints, pencils scratching furiously, eyes tracing lines that will define the future battlefield. Military officers pace along the polished concrete, their breaths visible in the frigid air, murmuring over numbers that must meet impossible deadlines. Workers, hands raw from metal and oil, move in a synchronized dance, their movements measured, precise. America has no tanks. Its armored divisions are shadows of the mechanized armies rolling across Europe. Yet in this factory, under fluorescent lights and the roar of machinery, a new chapter is beginning. Steel and sweat will combine to birth the M4 Sherman, the tank that will carry the weight of a nation's unpreparedness into the battlefields of World War II. The first lines are drawn. The assembly begins, and the United States is about to catch up to a war already in motion. By 1939, Europe had already plunged into the horrors of mechanized warfare. Germany's blitzkrieg, lightning war, had stunned the world. In September, Poland fell within weeks, its cities reduced to rubble, its defenders overwhelmed by a combination of tanks, motorized infantry, and dive bombers. France, long considered a fortress of military planning, braced itself for the storm, while Britain mobilized its forces and awaited the inevitable. Across the Atlantic in the United States, the mood was markedly different. The country remained officially neutral, its military strategy cautious, underfunded, and heavily reliant on pre-World War I doctrines. American armored forces were almost non-existent. Tanks existed in small numbers, often outdated models, ill-equipped for modern combat. The U.S. Army had no experience with mass mechanized warfare. Doctrines emphasized infantry and horse-drawn artillery, and armored divisions were experimental at best. Military leaders, aware of Germany's success in Europe, were alarmed but constrained by Congress, public opinion, and the lingering isolationist sentiment sweeping the nation. Meanwhile, the industrial landscape told a different story. Detroit's factories, Ford, General Motors, Chrysler, were marvels of mass production, churning out cars that symbolized American prosperity. The assembly line, perfected in peacetime, had not yet faced the demands of war. These plants had the potential to transform the American war effort, but no one had yet bridged the gap between civilian manufacturing and the urgent needs of a global conflict. In early 1940, the War Department faced a stark reality. If the United States were to support its future allies or defend itself, it needed armored vehicles fast. Tanks were no longer luxuries. They were essential. But America had no infrastructure for mass-producing modern tanks. Designs were outdated, production lines non-existent, and skilled labor accustomed to cars rather than armored machines. The solution would come from an unlikely source: the very same factory floors that produce consumer vehicles. Ford Motor Company, under the leadership of Henry Ford and his son Edsel, had pioneered the moving assembly line. The company could make thousands of cars with speed and efficiency unmatched in the world. Could that same method be adapted for a war machine? It was a question the military and industry were about to answer under immense pressure. By mid-1940, government officials began negotiating with Ford and other industrial giants. The task was monumental: transform automotive production into armored vehicle manufacturing. Engineers pored over blueprints for the M4 Sherman, the tank that would become the backbone of Allied armored forces. Every detail mattered, from the welded hulls and turret mechanisms to the engine type and suspension systems. There was no room for error. The design process itself was fraught with challenges. The Sherman had to balance speed, armor, and firepower. Its 75mm gun was effective against most medium German tanks, while its gasoline engine allowed for rapid production and simpler maintenance. Yet compromises were inevitable. Thicker armor meant heavier weight, slowing assembly lines and reducing speed. Lighter armor risked vulnerability on the battlefield. Every choice was a negotiation between engineering possibilities and the strategic necessities of a war already raging thousands of miles away. Ford faced its own obstacles. Workers accustomed to car engines now welded armored hulls. Tooling had to be redesigned, assembly sequences rewritten, and supply chains adapted for steel plates rather than car panels. The River Rouge plant became a factory unlike any other, half industrial powerhouse, half military laboratory. Managers worked tirelessly to optimize assembly lines, introduce interchangeable parts, and cut production times without sacrificing quality. The human element was as crucial as the machinery. Engineers, designers, and laborers labored under constant deadlines. Morale swung between excitement and exhaustion. News of Europe's devastation, images of burned cities, destroyed tanks, and fleeing civilians filtered across the Atlantic, reminding workers that their efforts were not abstract. The tanks they built could determine the fate of nations. By late 1940, prototypes began to emerge. The first Sherman chassis rolled off modified assembly lines, crude but functional. Military officers inspected them meticulously, noting imperfections and demanding improvements. Field trials tested mobility, armor integrity, and gun accuracy. Every flaw discovered meant redesigns, delaying production but ensuring eventual reliability. Meanwhile, Germany continued to conquer Europe, its panzer divisions demonstrating the decisive power of armored warfare. The urgency could not be overstated. Political pressure compounded technical challenges. Congress demanded results, the military demanded performance, and industrial leaders demanded efficiency. Ford's management navigated these conflicting pressures, leveraging assembly line innovations to achieve what many thought impossible. Workers adapted quickly, using jigs, conveyor systems, and standardized parts to dramatically reduce production time. Where a tank once took months to build, Ford envisioned hundreds completed in mere weeks. By early 1941, the first batches of M4 Shermans were ready for mass production. The United States, previously unprepared for mechanized warfare, was on the verge of a transformation. Factories had become crucibles of innovation, where industry and military necessity collided with historical urgency. The Sherman's production was not just a technical feat. It symbolized America's entry into the war economy, the shift from peacetime indifference to wartime mobilization. And yet, questions lingered. Would the Sherman perform on the battlefield? Could an army that had lacked tanks for years suddenly wield mechanized power effectively? The answers would not come from blueprints or assembly lines, but from the battlefields of North Africa, Europe, and beyond. Ford's assembly lines rolled forward, each tank a testament to human ingenuity, industrial might, and the pressures of history. The first M4 Shermans were more than machines. They were the embodiment of a nation catching up to a war already in motion. As steel met fire and engineers met deadlines, the stage was set for the Sherman to become a symbol of America's industrial and military awakening. Inside the River Rouge plant, the work was relentless. Men and women, young and old, moved in coordinated precision along the assembly lines. Their hands bore the scars of welding, hammering, and fitting steel plates into place. The transition from car manufacturing to tank production demanded not just technical skill, but mental fortitude. Workers had to adapt quickly to heavier materials, tighter tolerances, and the looming knowledge that mistakes could have deadly consequences on distant battlefields. Engineers, too, carried the weight of expectation. Blueprints were revised daily as military officers inspected prototypes and demanded modifications. Welders and assemblers often stayed late into the night, checking every turret weld and suspension mount. Letters from soldiers overseas describing destroyed tanks, or newspapers detailing German successes, filtered back to Detroit, adding a psychological urgency. Each tank that left the line was a message. America was no longer idle. The human story extended to the officers coordinating production. They navigated between industrial managers and military commanders, translating battlefield needs into actionable factory requirements. Morale was fragile but resilient. Workers felt the gravity of their labor, but also pride. In the cold winter of 1940, amid the hiss of torches and the clang of steel, humanity itself became part of the machine. The M4 Sherman represented a careful balance of design, reliability, and mass producibility. Unlike German Panthers or Tigers, which were engineered for battlefield supremacy at the cost of speed and reliability, the Sherman prioritized manufacturability and adaptability. Engineers focused on standardizing parts, optimizing engines, and simplifying production methods to ensure that even if a tank broke down, it could be repaired in the field. Its 75mm gun could penetrate most medium German armor, while its gasoline engine allowed faster deployment and easier maintenance. Suspensions were strengthened to endure long-distance movement, and welded hulls were introduced to streamline production. The Sherman's design philosophy favored quantity and versatility over perfection, reflecting America's strategic reality. The country could not afford to produce a few perfect tanks, but needed thousands to tip the scales. Every component had to be engineered for mass production. Engines were adapted from automotive designs, transmissions simplified, and armor plates standardized. The technological challenge was immense, converting civilian assembly lines to handle armored vehicles with hundreds of moving parts and high-stakes tolerances. Innovations like jigs, conveyor modifications, and standardized fittings allowed Ford to reduce production times dramatically, setting the stage for one of the most significant industrial feats in history. Behind the machinery were leaders navigating uncharted territory. General George C. Marshall, Army Chief of Staff, understood the urgency of armored modernization. He pushed the War Department to contract private industry, emphasizing speed without sacrificing functionality. Political leaders, including President Roosevelt, balanced isolationist sentiment at home with strategic necessity abroad, endorsing programs like Lend-Lease even before full U.S. involvement in the war. Within Ford, Edsel Ford coordinated with military officials to translate battlefield requirements into production schedules. Decisions about engine types, turret configurations, and assembly methods often had to be made quickly, sometimes in hours, reflecting a leadership style that valued decisiveness and adaptability. Military liaison officers stationed in Detroit became crucial conduits, ensuring that design modifications aligned with real-world tactical needs. Leadership challenges were also human. Factory managers had to motivate tens of thousands of workers, maintain morale, and navigate strikes or slowdowns. The weight of expectations, both military and national, created pressure that drove innovation but also risked burnout. In those moments, leadership was less about command and more about orchestrating a human and mechanical symphony. Even before the first Sherman rolled onto the battlefield, its tactical significance was evident. U.S. military planners understood that future engagements would demand mobility, firepower, and mass. The Sherman, while not the heaviest or most armored tank, could be produced in vast numbers, allowing American forces to overwhelm enemy positions through sheer volume and coordinated attacks. Training exercises in 1941 simulated combined arms tactics. Shermans advancing with infantry, artillery support, and air cover. Lessons from North Africa and Europe shaped these exercises, emphasizing maneuverability over brute strength. The tactical philosophy behind the Sherman was clear. Speed, reliability, and numbers could offset the advantages of more heavily armored German tanks. The design reflected a deep understanding that battles would be won not by individual tank duels, but by coordinated mechanized warfare. Across the Atlantic, German tank successes loomed large. Panzer divisions had demonstrated the devastating power of mechanized warfare, conquering Poland, France, and pushing toward the Low Countries. The Germans had superior armor and more experienced crews, but their designs were complex, slow to produce, and maintenance-heavy. American observers took note. Quantity, reliability, and adaptability could counteract superior individual performance. The Sherman's development was directly informed by enemy performance. Engineers and military analysts studied German tanks, understanding their strengths, armor, firepower, a psychological impact, while identifying weaknesses such as mechanical fragility and logistical demands. In designing the Sherman, U.S. forces sought a tank that could be mass-produced, repaired easily, and deployed wherever needed. In essence, they designed for the long game, a tank not to dominate one battle, but to sustain a global war effort. Finally, the production of the Sherman carried moral weight. Workers knew that every completed tank could save lives overseas. National sentiment was shifting. Americans began to recognize that isolation was no longer viable and that their industrial output could shape the outcome of distant battles. This urgency translated into innovations on the floor. New welding techniques, standardized armor plates, and conveyor modifications reduced production bottlenecks. By 1942, Ford's innovations allowed hundreds of Shermans to leave the River Rouge plant each month. The human, technological, and moral forces converged. Engineers optimizing machinery, workers performing with tireless precision, leaders coordinating resources, and military planners translating design into tactical doctrine. Each angle, human, technological, leadership, tactical, enemy, moral, was a thread in the fabric of Sherman production, creating a machine that embodied the United States' industrial and strategic awakening. By late 1941, the first M4 Shermans had begun rolling off Ford's assembly lines. The River Rouge plant had transformed from a civilian car factory into a mechanized armory, its floors humming with the rhythm of mass production. Each tank was a symbol of America's urgent leap from unpreparedness to armored capability. Engineers scrutinized every weld and bolt. Military inspectors measured gun alignment and armor integrity. The pressure was immense. Every delay could have consequences thousands of miles away in the European and North African theaters. The first Shermans were shipped to Britain under the Lend-Lease program, a lifeline to allies struggling against German mechanized dominance. Convoys crossed the Atlantic, the tanks packed tightly on Liberty ships, their steel hulls rattling against each other in the rolling waves. Sailors and soldiers watched anxiously, aware that these machines represented more than mere hardware. They were the promise of American industrial power backing the fight against fascism. In North Africa, General Dwight D. Eisenhower and his commanders prepared to integrate these tanks into the Desert War. The early Shermans faced harsh conditions, sand-clogged suspension systems, extreme temperatures stressed engines, and long supply lines tested fuel reliability. Field crews quickly learned the tank's strengths and limitations. The Sherman's reliability allowed rapid advances where German and Italian vehicles faltered, but the lighter armor left crews vulnerable to heavier panzer guns. Crews improvised with sandbags, extra plating, and tactical maneuvering to survive engagements. The decisive moment came during Operation Torch in November 1942, the Allied invasion of French North Africa. Shermans spearheaded the armored assaults, their engines growling across deserts and rocky passes. Against Axis forces, the tanks proved crucial. Mobility allowed units to outflank entrenched positions. Firepower suppressed enemy infantry, and sheer numbers overwhelmed German and Italian formations. Commanders marveled at the logistical feat. Tanks mass-produced in America, transported across oceans, and deployed effectively in a hostile environment. The human dimension was never far from the forefront. Crews shared small victories and losses in cramped, hot interiors. Letters from soldiers described the relief of having a dependable tank to rely on, a machine that could endure desert trials and still maintain offensive momentum. Engineers in Detroit monitored reports with a mixture of pride and apprehension. Each operational success validated months of labor, innovation, and sacrifice back on the assembly line. Meanwhile, in Europe, the Sherman was preparing for its next test. By mid-1943, North African campaigns concluded, and attention turned to Sicily and mainland Italy. Sherman battalions provided the spearhead for invasions, combining mobility with artillery and infantry coordination. The tanks demonstrated their strategic value. Quick repairability allowed damaged units to return to the front, and interchangeable parts simplified field maintenance. Allied commanders adapted tactics to maximize the Sherman's strengths while minimizing exposure to heavier German armor. The Normandy landings in June 1944 marked the ultimate trial. Thousands of Shermans crossed the English Channel, disgorged onto beaches under heavy fire. Artillery shells and mines tore through some tanks, but others pushed inland, supporting infantry and securing bridgeheads. Crews faced constant threats from German Tiger and Panther tanks, which could destroy Shermans at long range. Yet superior numbers, coordination, and tactical ingenuity allowed Allied forces to advance. The Sherman's mechanical reliability and mass availability had become decisive, offsetting enemy firepower and contributing to the liberation of France. Every engagement highlighted lessons learned on the assembly lines. Engineers monitored field reports, feeding back modifications, improved radio systems, updated suspension parts, and reinforced armor plates. Leadership remained hands-on. Commanders on the front lines communicated directly with design teams back in Detroit. The feedback loop between production and battlefield performance exemplified a new form of warfare: industrialized, responsive, and relentless. The climax of a Sherman story was not a single battle, but the culmination of global coordination. American factories, once focused on consumer automobiles, had become war engines. Convoys transported tanks across oceans. Soldiers integrated them into complex campaigns spanning deserts, mountains, and plains. Each Sherman that survived to support the next advance represented not just a mechanical triumph, but the effective orchestration of human effort, industrial ingenuity, and strategic planning. Even as victories mounted, challenges persisted. German tanks could outgun Shermans in one-on-one duels, and field commanders had to adapt tactics constantly. Crews learned to avoid frontal engagements with Tigers, rely on maneuver and cover, and use combined arms tactics effectively. These adaptations reinforced a key principle. The Sherman's value lay not in invincibility, but in flexibility, reliability, and sheer numbers. By late 1944, Shermans were a central component of Allied armored divisions across Europe and the Pacific. In the Battle of the Bulge, the tanks helped hold critical positions, often under extreme winter conditions, highlighting their versatility. In the Pacific, lighter armor-suited island campaigns, where mobility and speed were more critical than heavy protection. Across theaters, the M4 Sherman became a symbol of American industrial might, machines born in factories now defining the front lines. The climax was complete. From empty assembly lines in Detroit to the beaches of Normandy, from deserts in North Africa to the forests of Europe, the Sherman had transformed the battlefield. The decisive moment was not one tank firing a shot, but the realization that a nation could overcome initial unpreparedness through ingenuity, mass production, and relentless adaptation. The United States, once lacking armored power, had become a mechanized force capable of influencing the outcome of a global war. And yet, even as tanks advanced and battles were won, the consequences of production choices, design compromises, and tactical reliance on numbers would reverberate. The next chapter would examine the aftermath, battlefield losses, industrial achievements, and the enduring lessons of the M4 Sherman's rise. By the spring of 1945, the M4 Sherman had left an indelible mark on the course of World War II. Over 49,000 units had been produced by American factories, with an additional 7,000 manufactured in Canada under the Canadian Military Pattern Program. Ford alone accounted for tens of thousands, a staggering achievement given that barely 5 years earlier, the United States had virtually no operational tanks. The scale of production underscored the remarkable speed at which industry had adapted, transforming consumer assembly lines into the engines of war. The battlefield impact of Sherman was evident across multiple theaters. In North Africa, Shermans had outnumbered and outmaneuvered Axis tanks, compensating for thinner armor with mobility and logistical resilience. Crews were able to repair vehicles quickly, replacing engines, tracks, or turrets in makeshift field depots. This reliability allowed Allied forces to sustain offensives and exploit breakthroughs, turning temporary tactical advantages into strategic gains. In Europe, Shermans formed the backbone of armored divisions during the Normandy landings and subsequent campaigns through France, Belgium, and into Germany. While heavily armored German tanks like the Tiger and Panther could destroy a Sherman in a single engagement, the Allies mitigated this disadvantage through combined arms tactics, coordinated infantry support, artillery barges, and air superiority. The Sherman standardization and numbers made it possible to absorb losses and maintain relentless operational momentum. Reports from the front often highlighted crews' admiration for the tank's reliability, ease of repair, and adaptability to varied terrain, from the hedgerows of Normandy to the streets of Aachen. The human dimension remained central to the aftermath. Soldiers recounted both triumph and tragedy. Letters and diaries spoke of Shermans carrying troops into battle, providing a measure of protection and enabling offensives that would have been impossible without mechanized support. Yet the tank's vulnerabilities were also apparent. High casualties occurred in confrontations with superior German armor, and crews often relied on ingenuity and tactical maneuvering to survive. Field reports emphasized that success depended not only on the machines themselves, but on the skill and resilience of their operators. Industrial and logistical achievements were equally profound. Ford's innovations in mass production, interchangeable parts, modular assembly, and conveyor adaptation became models for post-war industrial engineering. The ability to produce large quantities of standardized tanks in record time demonstrated the United States' unprecedented capacity to mobilize civilian industry for wartime needs. Supply chains spanning the Atlantic ensured a continuous flow of steel, engines, and components to the front lines. Each delivered Sherman represented a tangible link between the home front and the battlefield, a testament to coordinated effort on an unparalleled scale. The Sherman also influenced strategic thinking. Allied planners recognized that the combination of mass production, reliability, and tactical integration could offset technological inferiority in individual units. German commanders, meanwhile, faced a dilemma. Their formidable tanks could destroy individual Shermans, but they could not match the Allies' numbers and industrial endurance. This insight would inform post-war doctrines emphasizing not only technological sophistication, but also the strategic advantage of massed, reliable forces. Beyond immediate military outcomes, the Sherman's production reshaped the American workforce and society. Factories that had employed thousands for consumer goods now engaged tens of thousands in war production, including women and minorities previously excluded from heavy industry. The experience accelerated social changes, expanded technical training programs, and fostered a sense of national unity and purpose. Ford's assembly lines, once engines of peacetime prosperity, became symbols of a wartime ethic, efficiency, adaptability, and shared sacrifice. Quantitatively, the Sherman's impact was undeniable. In North Africa alone, U.S. and British armored divisions, equipped largely with Shermans, inflicted disproportionate losses on Axis armor while maintaining supply lines and operational momentum. Across Europe, tens of thousands of tanks supported every major Allied offensive, with replacement and repair systems ensuring that the flow of Shermans never stopped. Every loss could be compensated, every damaged vehicle repaired, sustaining pressure that German and Italian forces could not match. Yet the aftermath also included sobering realities. Sherman crews faced persistent threats from superior enemy firepower. Casualties were high in certain engagements, particularly in the dense bocage of Normandy and in tank-versus-tank confrontations with Tigers and Panthers. Field commanders learned to value tactics, coordination, and intelligence as much as armor and firepower. Lessons from a Sherman's battlefield performance influenced not only wartime strategy, but also post-war armor design philosophies worldwide. By 1945, the Sherman had become more than a tank. It was a symbol of industrial ingenuity, military adaptation, and human perseverance. Its story highlighted how a nation, initially unprepared, could leverage technology, labor, and leadership to achieve a decisive role in global conflict. The lessons extended beyond combat. They demonstrated the potential of coordinated industry, rapid innovation, and collective effort under pressure. As the guns fell silent across Europe and the Pacific, the United States emerged not only as a victor in battle, but also as a global industrial and military power. Factories returned to peacetime production, yet the innovations pioneered for Sherman production, the assembly line modifications, standardized components, and mass coordination, would influence manufacturing and military planning for decades. The tank's legacy endured, a testament to what could be achieved when necessity met ingenuity and when human and mechanical effort moved in unison. From the rubble of conflict to the quiet of victory, the Sherman's journey reflected the broader story of World War II. Adaptation under pressure, the fusion of human determination and industrial capacity, and the interplay between technology and strategy. It was a machine born of necessity, yet it shaped history in ways that extended far beyond the battlefield.